Hello, hello. Today I have Mod Pods by Simon Piano and GDC, two of my favorite setters. Excited to try this puzzle. It's got a rule that I've been doing a lot of lately. I don't think I've done one live yet though. So I don't know. I think this is probably going to be a hard one, but I don't know. I feel like I'm pretty good at them. So we'll see how it goes. So normal Sudoku rules applies to the rules. We've got the digits 1 to 9 once each in every row, every column, and every marked 3 by 3 box. And then we have these split P lines, although these are called mod Ps because there's an additional rule. But in general, split P puzzles are like pill arrows, if you know what those are, but with the pill split up. So the basic rule, let's take this one as an example, is if I take all of the digits on a line, like let's say these were 6, 7, and 8. Well, these would sum to 21. So since these sum to 21, these two digits have to be in some order 2 and 1. Because of what the rule says, I'll just read the rule actually. It says digits on a line between two circles sum to a 2-digit number written using the digits in the circles. I guess I could use the instance that they use. So for instance, 3, I guess I couldn't do that here because I need 2 3s. So where can I do their example? 3, 3, 4, 6, 1 works here because I can have a 1 and a 3, that's 13, and this also sums to 13. So that works. I couldn't do, by the split P rule, I could do it this way with the 3 over here and the 1 over here, even though that looks like 31. The order doesn't matter on the circles. I can't do it by Sudoku here. The conflict checker is telling me that's no good. But I can do the concatenation of these two digits in any order, and that will still work. Now, Mod Pods have an additional rule, which is that the lines, not the circles, so the circles don't matter here. The lines between the circles are all modular lines. And what a modular line means is that every length of 3 on a line, so let's do this one here as an example, so this length of 3 on this line has 1 digit with a residue of 0 mod 3, 1 digit with a residue of 1, and 1 digit with a residue of 2. So you could do 1, 2, 3, that would be fine. And that would satisfy this group. But what's interesting about these lines, well, one of the things that's interesting is that if the line length is more than 3, then knowing the residue of 1 digit is going to tell me what it is 3 spaces away. So if this were 1, 2, 3, I would know that this digit is either 4 or 7, right? So again, just the residue classes here are 1, 4, and 7 as the 1 group, 2, 5, and 8, I'll call sometimes the 2 group, and 3, 6, and 9, which I might call the 0 group, these are all the residue mod 3. So 1, 4, 7 is a group. This digit's a 1, therefore this has to be from the same group. So why is that true? That's true because if these are all, these are 1 each, and these are also 1 each, then if this is not from this, then either I'm going to get a repeat in this group or a repeat in this group, right? So if this were, say, an 8 instead, then I'm not going to get one of each type here. So one of the common properties in these lines is that, and this is true for lots of like entropy lines, there's probably another one I'm forgetting, but these lines where you have groups with 3 digits each, where you need 1 from each group in every set of 3, the property you get from this is that the groups repeat every 3 digits. And on a parity line, you get a similar thing, but because it's every other, I think it's very obvious that if these were parity lines, you could do like 1, 2, 3, 6, something like that, and then you get every other digit is the same parity. Well, here I have 3 groups instead of 2, but the same idea applies. Every 3 groups, I get a repeat group. So anyway, yeah, that's it. Let's reset here and see how we can do. There are a couple notes here, but I'm not going to repeat those because they're just little helpful clarifications, and if they come up, I'll bring it up. So where do we start? I guess we start here because one of these has to be a 1 or a 2, because the most this could possibly be is 24 if it's 7, 8, 9. But the other thing that's interesting here is that there are 3, this is only length 3. So I actually know that the concatenation of these two digits also is 0 mod 3. So it could be, what could it be? It could be 12, it could be 15, it could be 18, it could be 21, or it could be 24. Those are the only possible choices here. And actually, I could do something similar here. Although, what's my biggest number here now? I think it'll be quite a bit bigger. I mean, the naive thing to do would say that's 30 and that's 17. But there's no way we can actually do that, right? So can I get well, if I did that, what would that be? 47? So 45 would be the biggest we could be. But that's a lot of, I mean, I think I'll get literally every digit if I try that. So is there a better way to do that? Well, okay, so these 5 digits are all different actually, because this digit sees all of these, and it's not 3 away from this one, so these are also different. So a better way to see it is this digit sees all of those, so these 4 are all different. This is also different from here by the modular line. So these 5 all have to be different, because these 4 are all different from each other by being in the same box, and this is different from all 4 of these. So these 5 are at least all different, which is at most 35. I could put another 9 here. Wait, could I put another 9 here? Yeah, these could both be 9. And then that would get us to, what did I say, 44. So 42 is the most we could be. That still gets every digit here, so I don't have to do that. How about here? This could be up to 30 something. Yeah, I'm not going to get rid of very much here by doing that. I don't think. Okay, this one also. This is the same as this line here. And here I could start coloring here because I have a whole. Oh no. These are 45. Maybe this is where we should start, because this is the whole box between these 2 circles. So these sum to 45, which means this is 1 or 2, because this is now either 24 or 15 actually. And I can maybe color, because these I'm noticing are all the same type. So if I color these boxes, let's say I make these blue. Because they're all 3 away. Let's make this one yellow and this one orange. Those, I think those are distinctly different. These are all the same. Like blue is one type, yellow is a type, and so of these 3, I need 1 of each. So that's going to be blue. I don't know more, but I can get rid of 4, 5, or 8 from here because this is at most 24. So I need a 1 or 2. It's not here, so it has to go here. This could still be 1 or 2. I was trying to see if that would cascade down, like the 1 or 2 has to be here, and it's not here, and it has to be, oh, I guess this could be bigger. Oh, but this is pretty small, right? What is this? This can't be 40, right? This could be most 30. So this, and it can't be 30 because we can't have a 0 here. So this is actually 1 or 2. And this one, how big could this be? I don't know, like why, this could just be 19, I think. I'm not sure why it couldn't. Oh, because of this one. How about here? Because this surely can't be, this could be at most 9879, which is 30 something. So that's 1, 2, or 3. Could this be 3 here? Oh no, it can't be 3 because it can't be 34. Wait, what did I say? 24 and that's 33 actually. So this can't be a 3 because of this one still. Yeah, so this is actually, well, it could be 22, I suppose, which is not that small. I'm thinking if this could actually be 11, We could do 2s here. And then 3, 4, I think works. So yeah, that works. So I think any of the 4 possibilities here still work. Could this still be 1 or 2 then? Yeah. Hold on. Could this be 21? So by the same logic, this is at least 15. I could repeat a 1 and be 16. That's plenty of space to 21. So yeah, I think 21 is fine. 5. Could this really still be a 5? How? Well, I don't think I can do 50 here. So it'd have to be... Could it... I think we can't do 45 either, because this is at most 35, 44. So we can't do 45. So if this is a 5, we have to do 15, which doesn't work. So this is not a 5. Can I get rid of more than that? I don't think so, because 1 and 2 could be 21 either way. 4 could be 42 or 24. 18 I think is fine. This could be 1, 2, 3, 4, 5. We have double 3s here. 5, 2, 1, 4. Yeah. No, hold on. If this is 18, I think we need a 1. Because if this is 2, 3, 4, 5, 6, that's already 20, which is too big for 18. So if this is 18, we need a 1 here, which means a 4 here. 3, and we can't have... Hold on. If this is 18, oh, it's 18. If this is 18, we need a 1 here. This would probably have to be 4. What's 2, 2, 3, 6? Hold on. Another way to think about this is these two could be as low as the low and middle of their group. These two could be as low as the low and middle of their group. And these two could be the lowest of their group identically. So the lowest way you could do that is to have does it matter which one you do? I don't think it matters which one you do is which. Right, so if the 1s are the lowest, we could have 1 plus 1, right? We have 2 1s plus 2 and 5 plus 3 and 6, which is what? 6 and 12 is 18. But if we did, this is say 1 and 4 instead, and these are both 3, I think you get the same sum, right? 5, 10, 18, yeah. So 18 works. If it were 18, it'd have to be 1, 4, and then this could be 3, 6, and 2, 2. That works, or these could be 3, and that could be 2, 5 for 18. Either way works though, but it just barely works. Can I do something with this? Yeah, I think 18 works. In fact, 18 seems pretty likely. What about this one? If this is... could this be as low as 14? If this is 14, that means what? How would we get to 14? 14 could be there'd be no 4. Well, 14 is 2, so these have to be from the 1 group with no 4. So 1, 7, 1, 2, wait, hold on. Did I mess that up? 14 is from the 2 group. I need 2 from the 1 group then. No. I need 2 from the 2 group, sorry. Because it's, these 3 add up to 0 mod 3. So whatever is duplicated is the same as this concatenation. So if this is 14, we have 2 in the 2 group. So we have 1, 3, 1, 2, 3, 5 is only 11. So we could do 1, 2, 3, 8. We can't do 4, so the 1 would have to be there. And then we want, so we have actually this, if this is 1, this is 1. Oh, that makes this 2 actually. I don't see why that's a problem. Actually, I'm noticing that these have to alternate types. Hold on. I think this coloring is not going to help. I think I need to color with these, maybe. And I was trying to see if I get to this, but actually I don't think I can. But let's follow this in case it helps. So one of the things about the number 3 that's cool is the way to tell if a 2-digit or any digit number is a multiple of 3, you can add the digits together, and if they add to a multiple of 3, then the concatenation of those digits also add to 3. So for example, the number 59, no, not 59, 51, right? If you didn't know that 51 was a multiple of 3, the way you would tell that is you add them together. Well, 5 plus 1 is 6. 5 plus 1 is 6, and 6 is definitely a multiple of 3. So 51, therefore, is also a multiple of 3. And if you don't get a number that you can tell, like let's say I had the number 1, 2, 3, 6, 9, 4, 8, right? So this huge number by itself, I have no idea if it's a multiple of 3 or not, but I can add them together. So that's 6, 12, 21, 33, right? Now 33 I know is a multiple of 3, but if I didn't, I could add 3 plus 3 to get 6, and I know that 6 is a multiple of 3, so that works. So if this is this has to be a multiple of 3 because I've got a 0, 1, and a 2. If I add those together, that adds up to something that's 0 mod 3. Another 0, 1, and 2, that's also 0. So this whole thing is 0 mod 3, so it's a multiple of 3, which means this 2-digit number, in whatever order, is a multiple of 3, which means those 2 digits added together is a multiple of 3. And since they can't both be 0 mod 3, or it can't be 36, for example, then whatever type this is, I don't know what type it is, we'll call it blue, has to be different than this type. And if we just think about the examples, right? If this is a 1, this is a 2 or an 8. It's either 21 or 12 or 18. Those are the choices, right? And if this is a 1, this is a 4. Actually, so wait. No. Where's 4? If this is a 2, this is a 4. Or a 1, actually, I guess. But they're different. They're from different groups either way. And the same thing's going to be true here, right? This is going to be also a different group because these 3 digits are a 0, 1, and a 2 in some order, which add up to a digit that's 0 mod 3. It's a multiple of 3. So these are the same thing. This is also 2 groups. So this is going to be yellow. This is going to be blue. I wish this is 4 and this is 4. I really want to get to this one because I suspect this one will have to be yellow. Wait, no. No, maybe it has to be blue. I don't know. It's going to be confusing. But this one is the same thing. This has to be yellow. And this now has to be blue because these are different. And so these are the same, actually, which what does that mean? It means that these aren't 3, 6, 9. Do I know more than that? If this is 14... So if this is 14, those are going to be from the 2 group. And if this is 25, which in that case would be yellow, and if these are 25, these would be from the, because 25 is 1 mod 3. So these would be from the 1 group, which is also yellow. Hold on, is that a general property of 3s? I haven't actually thought about, since like, I don't know, whatever grade you learned the trick about multiples of 3, why that works. Is that for any concatenation? Can I do something like that where the modularity of the sum of the digits is always the modularity of the digits, mod 3? Is that always true? Well, I don't know if it's always true, but these are definitely always yellow. Hold on, let me think about that for a second. Why would that be true? Because that's like a very interesting fact. So why is the multiples of 3 rule right? Is it just because you get to 30 and it kind of repeats? So, I mean, you can test by case up to 30, and then it has to repeat, but there's got to be a more satisfying way of thinking about it. Because, hold on, I'm getting bogged down in this, but this might be really useful actually for this puzzle. Because if I could do this as a generality, that's probably going to help with all this stuff. I guess there aren't that many connections left, so maybe I'll just let it. Maybe I'll do it on a case-by-case basis, and on my own time figure out why that's true. Why is the... Yeah, so obviously if the first digit's 0, it goes without saying. And then, so the reason 3, this works with 9 as well. And 3 is like a special case of 9 in some sense, where when you go past the tens place, you add 1. So when you go from 9 is 0 mod 3. If I add 1 more, I go to 10, which is 1 mod 3. So I add 1 and I go from 0 to 1 mod 3. So that still works. And then every time you add 1, it still works. So yeah, so that makes sense. So yeah, I think it is true as a generality then that if you add 1 to a number, you are adding 1 to its residue mod 3 by definition. But in the case of 3 specifically, because 3 times 3 is 9, which is 0 mod 3, which is 1 less than 10, which is the base, then when I go from 9 to 10 or 19 to 20, I am adding 1 to the residue because I'm adding 1 to the number, but I'm also, because that 9 is a 0 effectively, that 9 goes to 0, the tens digit goes up by 1. So its residue, the residue of the sum also increases by 1. Okay, so that is going to be true. So that's why generally it's true that the residue of the digits in the 2-digit number is going to equal the residue of the component digits in the sum. That's cool. I never thought about that, but it is. I think that's true as a generality, which means since these 2 digits are both blue, they're going to add up to something in the... So if these are in the 2 group, 2 plus 2 is 4, which is 1 mod 3. So 2 2s go to something in the 1 group, and 2 1s goes to something in the 2 group. So since these are both blue, this whole thing is in the yellow group. These 3 are 0, which means this has to be yellow, and these 3 are 0, which means this has to be yellow. So we get this, which means this is not yellow, right? So these 3 groups where there was one here, which is not blue. Hold on, can I tell what this is? This is not blue. Does it have to be yellow? Or could this be 3, 6, 9? I'm not sure. Well, there's 2 of these. Could this... Oh, this one can't be 3, 6, 9 because, look, there's 2 yellows here. One of these is blue. I don't know which one, but one of them is blue and this is blue. So there's 2 blues here as well. So in these 5 digits, I have 2 yellows, 2 blues, and whatever the zero group is. And there's two of a group here. So I can't have two blues or two yellows. So these is the other type, which are 3, 6, 9. And then these are yellow and blue, but I don't know which is which, I think. Oh, but I do, because this can't be blue and it can't be orange now. So this is yellow, which means these are blues, which means this is yellow. I must know this, right? No, this could still be blue. This is blue or yellow. Oh, I know this is yellow because I've got yellow, yellow. One of these is yellow. So I got yellow here. So there's a blue here for sure. There's a blue here for sure. So this is not blue. This is not blue. It's not yellow. This must be orange. This is 3, 6, 9. And then these two I'm not going to be able to discern from each other. Right. Yeah, I don't know. Okay. This is now yellow because neither of these are yellow in the column. And I need one of each here, so that's yellow. Which means these are not both yellow. And if this is blue, these would both be yellow by the same logic we just did this. So it is good that we did that in generality, because now I can label that as blue. No, not blue, as yellow. Sorry, as yellow. Which means these are blue, because these are both yellow. That is, it's a property I've never ever thought about, but it's a really neat, I love how this is all coming together here. It's really cool. I feel like it's a really complicated deduction, though, to have to do, to basically prove a math theorem. Maybe we could have done something more case by case here, but and since now these are different, so this whole thing is 0 mod 3, right? So the converse of this statement is also true, right? So not generally, but in this case it is. So if the sum of the digits is 0 mod 3, then the sum of the components is also 0 mod 3, but the converse is also true. If the sum of these is 0 mod 3, then the sum of the component digits, the number it represents is also 0 mod 3. So this sum is 0 mod 3, which means these are orange. And that makes this the missing one, which is blue. I feel like this is going to have to be orange, but I can't prove that. This is blue and yellow in some order. I have one of each here. Oh, these are also orange too, because by the same exact logic. So those are orange. So now I have 3 oranges here. So this is orange because I've got one group of 3 here, one group of 3 here. This is going to be the other group of 3. So there's one of each type in this missing section of the box. Because the digits 1 to 9 are, you could divide it up into 3 groups, like here, right? Right, here's a group, here's a group, here's a group. So all oranges in the row are taken. So this group's orange is here. I've got a yellow here. I'm not going to get more, I don't think. So now this is either 14 or 25. Can it really be 14? 3, 6, 2, 4. Not 14. 15 or 24. Sorry, these are different types. It's 15 or 24. I think 15 does work. 3, 6, 2, 4 just barely works. And I have no doubt 24 will work. What about this? Because these are the same. So can this be 14? If this is 14, we get 2 and 5 here at least. 2, 5, 1, 3 is only 11 actually. So actually we have room to spare. I'm going to get rid of some markings that are not helping. Like if I have orange, I know it's 3, 6, 9. I don't need to write 3, 6, 9 there. These feel like way overmarked, but I've ruled 5 out of here, so I'm going to leave it. Um, oh, look at this. These two digits are not 1 or 2, right? This digit is blue, which is the same as this. So this has to be at least 4 or 5 here, looking at this 2. This 1 or 2, right? Whatever that is. Because, so like this can't be 1. If it's 1, that's 2, and then these are different types. So we know they're the same type. Same with 1. It's not 1 or 2. So this is at least 4. This is also at least 4. So this is at minimum 9. And this is at least 3 plus 6 is at minimum 9. So this is minimum 18. So this is 20 something. And now we know what group is what. 4. Wait, this is 14. But we had room to spare here, so that does work. There's definitely a 2 in one of these. So this is 5 or 8. This is 2, 5, 8. This is a 1. This is yellow. So this is 2 or 8. This is blue. So it's 1 or 4. Now getting rid of that 5 is useful. So this can't be 12. So this is either 18 or 21. If it's 21, I don't think this has to be a 1. But it probably does. Hold on. This is 4 or 7. This is 22 or 28. It can't be 82. So let's think about this for a second. Could this be 28? 7, 8, 9, 4. It'd have to be maximized. I don't see why that's a problem. It would make this a 1, but I think that's okay, because then we get 18, which is fine. Okay. Blue and orange, blue and yellow, yellow and orange, blue and yellow. What's all my yellow? My yellows in this row are done, because there's one here. Oh, let's go back to 14, because that seems pretty... So there's definitely a 2 here in one of these. So this is 5 or 8. There's definitely a 2. There's definitely a 1 in one of these. So this is a 1, right? Because if I try to do there's no 4 here. So if I try to put 7 here somewhere, then we need the other 3 digits to add to 7, which can only be done with 1, 2, 4, which doesn't obey modularity and has a 4. So that breaks. So I need a 1 here. It can't be here by Sudoku. So that's a 1, which is blue, which means this is orange. That's a 7, which probably does something here, right? Because 24, 12, and 9 is 21, actually. So I do have one. I have one, I call it a degree of freedom, but basically I can either flip this 5 to 8, or this 3, 6 can become 3, 9. Either way, there is a 3 in one of those. So this is 6 or 9, which probably means this is 21 instead of 12, but let me think. Could I do 3, 6, 1, 5? Because there's no 2 here. So the yellow here is at least 5. 5, 6, yeah. The yellow here is at least 5. The orange here is at least 6. That's at least 11. I can't do 1 here. So this actually is 21 instead of 12. That's a 4. Which makes that a 5, I guess. I should take off combo checker, but it's... I'll take off combo checker. For pencil marks. I think... So this is 21. This could this be in... With 21, I think I have a lot of freedom, though. So there's at least a 5 in here. 5, 9 is 14. 1, 6 will be fine. Okay. I need a 4 in here. Well, there's no blue here, so this is blue. Blue is done. This is yellow and orange, so this is orange, which finishes orange here. So these are all blue and yellow. There's a blue and yellow here and a blue and yellow here. So I know the order here now because I get a blue here, a blue here, a blue in one of those 2 spots, which means this can't be blue, but this is a blue-yellow pair. So this one's yellow, and this one's blue. This is yellow or blue and not orange. So my two oranges in this box that I still need are both here. I guess that's yellow. That's just what I need is a yellow. 3 oranges, 2 twos. This is 1 each, which of course it is. This is a yellow and an orange. Okay. Could this be 7? 7 and 6 is 13. That would leave 8 left. 3, 5 it would have to be. But that works. One of these is a 5. One of these is a 2, actually. So there's a 2 here. I don't think that's worth putting. Okay. Well, this is 18 or 21. 18 is forcing, but 21 I think, clearly is less forcing. Can I do 21 without a 1? Because the only place 1 can go on this whole line is here. Can I do 21 without a 1? No, I can't do 21 because this is, these are all 5 different digits as we said before. So if this were 2, 3, 4, 5, 6, that's already 20. I would need a 1 to make 21. I can't do 21 in 6 digits without a 1, given that these 5 have to be different. So there has to be a 1. The only place 1 can go on this is here. So these are blue. These are yellow. Yellow is now done in this column, which gives me this is orange and this is yellow. I don't think I know that still somehow. Hold on, I've got 2, I've got 3. So this isn't yellow. This is orange or blue. Doesn't help me though. Oh, I have a 5-8 pair here. So that is a 2. So it's 21. This is 22 now, which is a little bit more restricted, but this could be 2, 3. So I have a lot of, actually, is it, this is a 4. No, high end is still, I have plenty of room either way, I think. Yeah, I don't see how I would do anything interesting there. Okay. I need a 7. This is 15. Can I do something with that? Probably not. It's like the 15 is the most obvious thing this could be. If I put a 7 here, because this isn't blue, if I can show that this can't be blue here, I at least get one color in. Oh, hold on. This is blue, yellow, and I have 3 blues in this column. So that's yellow, that's blue. That's therefore 7, that's 1. These can't be blue, these can't be blue, so my blue goes here. I need another blue which can't in this column, and it can't be here. So this is blue. So this has to be orange because yellows are done. This has to be yellow. This is a yellow-orange pair. This is a yellow-orange pair. This is a yellow-orange pair. So this is also a yellow-orange pair. Not that I think that's very helpful yet. Can this be 7? I would need 8 then, which would be 2, 6, but that's fine. 2, 6 is fine. There's a 2 in one of these, so there's a 2 in one of these. Right, so 18 is what this could be if I minimize. So if these were the same, and they're lowest. I don't think this can be 8, because if I have 2, 8, 4, 3, 6, what is that? That's 10, 15, and 9 is 24. Yeah, so this can't be 8. That has to be 5. And I've got 9 here, so these sum to 12. So this is only 3 or 6. So one of these is definitely 9. This is 3 or 6. One of these is definitely 3. Because if I have 6, 9 here, that's already 20. 695 is 20 already. I would have 21 like this. In fact, does this have to be 3, 6? If I have 3, 9, that's 12. And 6 is 18. And 4 is 22. Yes, this has to be a 3, 6 pair. There's a 9 in here. Oh, this is it. This is the degree of freedom I had. This has to be a 2. This has to be a 4. Because if this were 7 even already, right? 3, 6, 9, 10, 15, 17. Wait. I messed up. No, I didn't, but I just did something wrong. 10, 15. If this were 7, that'd be 22. Sorry. I think I added from the wrong number. 17 would be 22. That's already too big. So that would be 4. Yeah. Once this was not a 2, we lost that degree of freedom here. So everything was set then. And now this can't be a 2, which means nothing because this could still be 2, 5. In fact, no, this could be 2, 8 still, I think. Right? If this is 14, 1, 3 still works. This is just a 2, 8 pair. So now this is 11. So these are 11. 8 would go with 3. 2 would go with 9. This is 24. Minus 7 is 17. So it's either 3, 6, 8 or 3, 9, 5. Obviously, the 3, 6 and 3, 9 could go this way. So where am I supposed? So I know these two are a blue and an orange, which means this is blue. I guess I could just look at this column. That's blue. One of these is a 1. It's here. There's a 1 here. So this, I guess we could still have 8, 9, 1. Well, no, hold on. This can't be 8 now. Because if this, so this is 2 or 5. If this were an 8, this would be 18. With a 1 would mean 2 just be 17 left. But those two just be 8 and 9, and 8 would be used. So this is 2 or 5. 12 would make 11 left, 2, 9. Yeah, would be lots of choices. Well, 2, 9 would be gone actually because the 2 would be gone. So it would be 3, 8 or 6, 5. If it's 15, we'd have 1, 6, 8. I don't think, so if it's 2, yeah, so there's too many choices. How about this one? Because so this is 5 or 8. If this is a 4, we get 8, 7, 9. Hold on, 7 looks up here, so this blue is 7. Like, where's the 7 in this box? It's got to be there. So there's a 7 here as well. So this is a 7, 9 pair. So my blue and orange are 7 and 9. And then if this is 8, it's 4, and if it's 5, it's 1. Ugh. Either way works, I think, though. Okay, so then where can I, what about this one? This can't be 15. This can't be 15, so this isn't a 1. Right, if this is a 1, this would be 5. I can't get to 51. So this is a 4. That's an 8. That's a 2, because it can't be 54 or 45. So this is 24, which means this is 21. Does that mean it has a 9? No, I could do 8, 6, 7 still. That still works. Okay. So, but this is now 6 or 9. It can't be 3. I have, what do I have? I need a yellow, which is not 5, and an orange, which could be any of the oranges here to make 15. What about this one? So this could be 12 or 21. If it's 12, these add up to 27, which means these add up to 18, which seems fine. Oh, that's a 7, actually. There, let's do some Sudoku on colors. So that's a 7 because it sees 4 and 1. So that's a 4. These now add up to 11. Surprisingly unhelpful. Well, if this is 21, well, this is 7, does 21 still work? If this is 21, oh, I can do 21 with a 1 here. So this is 12. Because at 1, I would need 2 digits that average 10, which doesn't make any sense. So this has to be 12. So 12 and 15 is 27. These are 18, which is exactly, these add up to 11. Okay. So this is an 11, this is an 11, and then the other ones are an 11. That's wild. Okay. It's perfectly balanced in this row 8, so I should not look there. I feel like I need a new orange-yellow color to keep coloring through here, but I'm not going to do that. I have a 2 here by Sudoku because I need a 2 in this row that's not here or any of those. Finish the coloring. 8 here. No, not helpful. I need a 4 here. That finished by Sudoku. That finishes my blues. This is orange. This is orange. No, these are both orange. That's a 3, 6 pair, which makes this 9. Is that right? Hold on. Yeah, because 9 has to go up here because of this. I need 2 oranges here because blue and yellow are done. So it's a 3, 6 pair. And that finishes this. This is one of each of blue and yellow. That surely did hit. This is 22, 10, 14. That's 8. This digit is here. I think it's gonna end. Okay, let's try to do it more. So this is 9. This is 21. So these are 12. Yeah, which is what we knew. But now we know that's 6. So that's 6. This is 3 or 9. This is still, what do we say that was? This is 24. So this is 21. If it's 9, we have 12 left, which could be 5, 7, or 4, 8, I think. I don't see why not. 2 has to go here by Sudoku, so that makes this yellow. That makes these orange, makes this yellow. So this is an 8, which finishes, no, it doesn't finish. It just does something there. Oh, blue. So this blue, how did I get this blue? Oh, I'm going to trust that I got it right. So that's blue. This yellow makes this yellow. I don't know how long I've had those, but we've got those now. I should know these digits at least. These are 1 and 5. Not helpful, unfortunately. That's 5 or 8, also not helpful. This digit is here, which means it's not 6. Because it's not those two. And those are the 3 oranges in the box. Yeah, these 3 are the same. Does that help me get anywhere? And it's not 6, so it's here as well. And it's either of those. It doesn't help. Yeah. No, it doesn't help. Okay. 165, I think, still works. Yeah, 165 or 138. 129 is gone. Oh, these are 11, so that's 9. Yeah. So these continue on. Oh, but the 9 fixes all these. 3, 9, 3. Makes this 3. It was this one, right? Yeah. 3. There's a 9. One of these is an orange 9. Oh, but not here. This is a 9. So this is an orange 9 by Sudoku. So, but 2, 9 is gone. Ah, not helpful. Oh, 3, 6, 9. This is an orange. So it's 1, 5, or 8. I get a 1, 5, 8 triple here. So this is blue. I think that's right. Hold on, let me just make sure. Hold on. How could this not be blue? If this is not blue, it's yellow. These are all yellow. That makes this, so the blue here is 1, is the important point here. The blue here on this line is 1, which means that if this is not blue, then in this column I need 2 blues, which will be here and here, but they would both have to be 1. So this has to be blue, which means this has to be yellow. That's 4, that's 7. Doesn't, how does that, oh, it doesn't help because we know the blue here. That's 4. Don't know that yet still. Oh, but I can't put 1 in here because this is some 21. So this has to be a 1. There's a 7 in here. So 7, so these add up to 21 minus 7. So 6 would go with 8 and 9 would go with 5, which of course, yeah, okay. So we get 7 with 5 or 8. That's not 8. I get, I feel like we're so close, and yet, how do I finish this off? There's 2 in this row is here. How does this finish? 3. One of those is a 3. Not helpful at all. Maybe forget the colors. Let's do regular Sudoku. I need 3, 6, and 4 here. The 4 will go here. So this is blue. This is orange. Orange, orange. I still don't know. Oh, the orange 3, 6. Hold on. Yeah, this is going to be this digit. This is going to be this digit. It's going to be something like that, right? Hold on, I don't know. I might have to color 5s and 8s or something, but let's give me a minute. 3 here. 3 makes this 6, 5, 8. 9, 6. Because these have to add to 11. So this is now 1, 3, 8. This is not 1 or 8, so this is the 3. We'll finish the color, do more of the coloring. 3, then that's 6, that's 9, which means this is 5, 7. That's 8. 6, 9 resolves these. 5, 8 here has been resolved. 8 looks down here. So this is blue. This is yellow. This is 5, which is yellow. So this is blue 1. This is 5. This is therefore 7 in blue. This is therefore 5 in yellow. This will be 7 and blue, making this orange. Let's be 9, and this missing digit here is our 3 in the quarter, which I did not leave on purpose, but was nice. Cool. Yeah, it was a lovely puzzle. I really enjoyed that. So yeah, thanks for watching. Thanks for setting, and I will see you next time.